Alright, next video is 5.8, applying special right triangles. This will be the last one for Chapter 5 material, and then we're going to move on to the first 4 sections of Chapter 8. Chapter 8 deals with a lot of right triangles, and that's why we're doing 5.7 and 5.8, because it really helps form up our right triangle skills that we need to have to do this. So, the objectives are to justify and apply properties of 45, 45, 90 triangles, and to justify and apply properties of 30, 60, 90 triangles. Alright, so a diagonal of a square divides it into two congruent isosceles right triangles. So first, let's just look at that idea right here. This square, if this is a square, all these sides are congruent. The diagonal can cut this into two different triangles. So let me redraw this blue triangle over here. So since this square got cut down the diagonal, this corner still stays 90 degrees. These two sides stay the same. And since these are isosceles, these have to be the same. And the only number that works for that would be 45. So these numbers are 45 degrees. Since the base angles on isosceles triangles are congruent, the measures of each angle is 45 degrees. So another name for an isosceles right triangle is what we're going to call the 45, 45, 90 triangle, because that's the angle measures. 45, 45, 90. This is your first buzzword, 45, 45, 90. And basically, the cool thing about this is that it's going to give us a lot of shortcuts because it's so specific. A lot of triangles that are right, we're able to do things like find the Pythagorean theorem and find a missing side if we're given 2. Since this one is such a specific case, we're able to do more information. We're able to do more things with less information. So that's basically what we're going to do. And then finishing off, a 45, 45, 90 triangle is one type of special right triangle. You can use the Pythagorean theorem to find a relationship among the side lengths of a 45, 45, 90 triangle. All right, please copy this diagram down with the L's, the square root of 2's. If you want to color code it, great. If not, that's fine. I would suggest doing that just so you know. So basically, the idea here is that the legs are always going to be the same because it's isosceles. So if I just gave you this L and asked you for this side and this side, you would be able to just duplicate it over here. And the hypotenuse, you literally just stick a square root of 2 on it and call it a day. Or reduce it if necessary. But all you do is just stick a square root of 2 behind it. And that's all you have to do. Alright, so let's do an example real quick. Let's find the value of x and y. Since this is a 45, 45, 90 triangle, the legs are congruent. So y is going to equal 8. When I have the leg, to get from a leg to the hypotenuse, all I do is multiply a square root of 2. So when the leg is 8, I multiply by square root of 2 to get the hypotenuse, and I get 8 times square root of 2. This is in simplest radical form, so you can stop. So we have x equals 8 square root of 2, and y equals 8. Alright, when they give you the hypotenuse, you have to work backwards. So when we went from side, this was the easiest way. Side to hypotenuse, because you just multiply by a square root of 2. To go backwards, hypotenuse back to the side, you have to do the opposite and divide by square root of 2. So if I have 5 as the hypotenuse, this S represents a leg. If I ever say S or side, that means the leg. Hypotenuse is obviously hypotenuse. Alright, so to get from the hypotenuse to the leg, I have 5. I need to divide by square root of 2. And I get 5 over square root of 2. But of course, algebra comes along and makes this more difficult. And we cannot leave radicals in the denominator. In simplest form, a radical, a square root symbol, cannot be in the bottom. So what I do is I want to change this so the bottom does not have a square root in it. Now what I can do is I can multiply this by a fraction. If I multiply this by 3 over 3, it doesn't change it. It doesn't help me, but it doesn't change it. 3 over 3 can be reduced to 1, same as 4 over 4 and 8 over 8. These are all reduced to 1. When the numerator is above the numerator and denominator, you can think of it as just the same, it's 1. So square root of 2 over square root of 2 is also 1. This reduces to 1. And what's nice is that that's what we're going to put here, because this is multiplying 5 over square root of 2. When I multiply it by this, it doesn't change the value. It still stays the same, because I'm just multiplying it by 1, so I don't alter it at all. And you'll see why this is going to help you. So go ahead and multiply these across. We have 5 root 2. Then we have square root of 2 times square root of 2. When you multiply square roots, you can put all of them in the same root symbol. This becomes the radical. This becomes square root of 4. And this is a perfect square, so we're going to go ahead and put this as 2. 5 root 2 over 2. This is the answer for x. So again, when they give you the side, you just multiply by square root of 2. When they give you the hypotenuse, you have to divide by square root of 2. And then if you have a square root in your denominator, you have to go back and multiply it to get it out of there. Alright, go ahead and copy this triangle down, the 30, 60, 90 triangle. This is your second buzzword. We're going to use S for the sides. S is the shortest side, 2S is the hypotenuse, S squared root of 3 is the long straight side. So basically what you need to know here is you've got more shortcuts. If I give you a 30, 60, 90 triangle and I give you this red side, all you have to do to find the blue is double it. All you have to do to find the green is just tack a square root of 3 up behind it. So this one, if I give you the red short side, that's the best case scenario, because then that's two easy things. Double it, square root of 3. If I give you one of these, you have to work backwards to the red and then go to the other one. So we'll see that in the next example. Please get these copied down. Alright, so example 3. Find the value of x and y, give your answer in simplest radical form. To go from the short side, x is going to be the short side, I'm going to call it S. To go from the short side to the hypotenuse, I multiply it by 2. To go from the short side to the long side, this long straight side, I have to multiply it by square root of 3. Now, since I don't have the short side in this problem, I have to go backwards to get to here. So since I have the hypotenuse, I want to go hypotenuse backwards to the side. In order to do that, I need to divide by 2. So the hypotenuse to the side, divide by 2. Hypotenuse is 22, so to get to the side, I divide by 2, so I should get 11. 11 equals x. So you can check this. If I put 11 in for x, this is the short side, I double it, I get 22, so it's good there. Now that I have the s, I have the short side, now I can find y, because I just tack on the square root of 3 and I'm done with it. So it's just short side to the long side, multiplied by square root of 3. Since I had 11, this becomes 11 square root of 3. That's all you do for this one. So again, the easiest way is when I give you this short side. If I gave you this short side, you find this by doubling it, and you find this by tacking on the square root of 3. Alright, this one is a little more difficult because they give you the long side and you have to find this one. So again, we have short to long. We multiply by square root of 3. So to go to long to short, I have to divide by square root of 3. And the best way for you to remember, on the 45, 45, 90 triangle, you're multiplying by square root of 40, or square root of 2. On the 45, 45, 90, multiply by square root of 2. On the 30, 60, 90, you multiply by square root of 3. And a good way to remember which one you multiply by square root of 3, which one do you do square root of 2, you're either multiplying by square root of 3 or square root of 2. On the 30, 60, 90 triangle, you have 3 different angle numbers, a 30, 60, 90. So those 3 go with the square root of 3. A 45, 45, 90 has two different values, 45 and 90. So those two different values go into the square root of 2. So that's kind of could be a helpful way of remembering how to find the square root of 2. You need to remember when you multiply here you double it, here you multiply by square root of 3. The 45, 45, 90 should be pretty simple because it's just two different sides and you know which ones are going to be congruent. Alright, so back to this problem. I need to get from the short side to the long side. But since I don't have the short side, I have to go from the long side backwards to the short side. So I divide by 3. So long to short, I've got 15. I'm dividing by square root of 3. Divide by square root of 3. So the short side becomes 15 divided by square root of 3. That's the short side. But now, again, dang algebra, we can't leave these square roots in the denominator. So I need to go in 15 over square root of 3. I need to multiply this by something to where I keep it the same. So I need to multiply by a value of 1. I don't want to do 2 again like I done in the last one. I want to do some kind of square root over square root. And I'm going to pick 3 because that's what's in here. You basically, when you decide what to put over here, it's just whatever's in this square root. So when you multiply things over, you have 15 square root of 3. Square root of 3, since I have two square roots, I can put the 3's inside the same root and just save me some time. This becomes 15 root 3 over square root of 9. 3 times 3 becomes 9. Alright, so keep going. This becomes 15 root 3. Square root of 9 becomes 3. 15 and 3, since these have a common term, the 3, I can cancel the 3 out of this one, it becomes 1. The 3 out of this one, it becomes 5. So my final term for x is x equals 5 square root of 3. That's the short side of x, where x is. Now, to get from the short side to the hypotenuse, the rule was just double it. So if this is 5 square root of 3, I have to double it and I get the hypotenuse. So I'm going to take 2 times 5 square root of 3. When you are multiplying a whole number into this type of problem, you don't multiply it into the square root. This is kind of like an x. You just leave the x symbol there, but it's going to be square root of 3. So you just multiply the 2 and the 5 and you leave this alone. If this were to say square root of 2 times 5 root 3, then you multiply the 2 and the 3 together and you leave the 5 alone. But since this just says 2, I'm just going to multiply the 2 with the 5. So y equals 10 square root of 3.